Hello friends, welcome to my YouTube channel, Learning Videos. So this video, we are going to see the code for finding the partial derivative and Jacobian. This is the first lab experiment for Mathematics Lab. So now, this is the question that find the partial derivative and Jacobian. I'm running this code in Google Colab. If you want, we can run this in PyCharm or Jupyter Notebook also. To run this code in PyCharm, I have made a separate video. I will paste the link in the description box. If you want to know how to install that, so you can refer that video and you can install in your system. So I'm running this program on Google Colab. Before starting this code, let us check how the program will go. Now, whenever an expression is given, so this is the expression, that is functions, that is x squared plus yz plus sin x. The function 2 is e raised to y plus xy square. F3 function is x plus y plus z. So these are the three functions that we are using in our program. Now first what we will do is we will calculate the partial derivative on this. Partial derivative on function 1 with respect to x. So if we differentiate this function with respect to x, we are getting 2x plus cos x. So likewise, we'll differentiate function 2 with respect to, we'll differentiate function 1 with respect to y. So we'll get z. We'll differentiate function 1 with respect to z. So we'll get y. Likewise, we'll go for function 2. We'll differentiate function 2 with respect to x. We'll differentiate function 2 with respect to y. We'll differentiate function 2 with respect to z. Likewise, we'll go for f3. We'll differentiate function f3 with respect to x, with respect to y, and with respect to z. So once differentiating the three functions with respect to x, y, z, we'll put that in the form of a Jacobian matrix. So now, whatever we have differentiated, we have got the values, we'll put in this matrix. So this is called as Jacobian matrix. We will evaluate this at the value of x, y, z as 1, 2, 3. Okay, we'll substitute the value of x as 1, y as 2, and z as 3 in this, and we will compute the value. Now, once computing the value, we will put that in terms of a matrix. Okay, so this will be the flow of the program. So the question is finding the partial derivative. So we need to find the partial derivative and the Jacobian. Okay. The first line of code states that I'm importing a package called as SynPy. Okay. SynPy is a package, just for your knowledge. SynPy is a package or module that can be used for calculus or differentiation. Okay. For calculating the Jacobian value, for matrix multiplication, everything. Okay. SynPy. Okay. So now I am importing SynPy as what? SP. SP in the sense I have given SynPy a name called as SP. So whenever you use SP, so that will internally call the module called as SynPy. Okay, I hope we have understood this. Now, what we have done is first we have declared the variable, defined the variable that is x, y, z. Okay, you can see over here we have defined the variable x, y, z such that if x, y, z should be treated as symbols. Okay, it should not be treated as variable, it should be treated as symbols. Okay, so for that, what line of code we have used? SP, as you know, SP calls the SynPy from a module. So now SP dot symbols, and whatever symbols you are using, that is x, y, z, and denoting it as a symbols. So after this line of code, whenever your program encounters x, y, or z, it will treat that as a symbol. So these are the functions that we have written. So one more thing, guys, in Python, if you type hash, so that will be treated as comments. Okay, for your reference, I have written this. So function 1, that is x square plus y into a z plus sin x. F2 is e raised to y plus x into y square. F3 is x plus y plus z. So these three are the functions. So these three are the same function that we have used over here. You can see this, these three are the same function that we have used over here. Okay. Here, whenever there is an x square in Python, we need to write double star. If you write single star, if I write x into x star 2, that means it is 2x. If I write x star star 2, that means it is x raised to 2. Okay. The highlighted portion over here, you can see x star stars 2. This means that x raised to 2. Okay. Since we have x square over here plus x into, sorry, y into z plus sp dot sin x. So why I have used sp dot sin x? Since sin x we are using, so to denote that this is a sin x function, so we are using sp dot sin x. Okay. The value of the x is nothing but x is variable. So we have already said our Python code that treat x, y, z as a variable. Okay. Same thing we are defining function 2. So sp dot exp, that is e raised to y, plus x star star 2. Star star 2 why we are using? Since it is y square, we are using star star 2. The f3 function is straight away, that is x plus y plus z. We will group that in terms of a matrix. So how to group that in terms of a matrix? So I am creating a variable. F means I am creating a variable named as f equal to, I am calling a function called as sp dot matrix. So now what this sp dot matrix will do? It will arrange the function f1, f2, f3 in the matrix form. Okay. sp dot matrix, what it will do is it will arrange the function f1, f2, f3 in the matrix form. I'm creating a variable called as var. I'm calling one more function called as sp dot matrix. I'm calling this sp dot matrix one more time, and I'm filling the values of x, y, z. Okay. So in first here, f, I have created a f, that is vector function. I'm arranging function 1, function 2, function 3 in it. Next, I'm calling one more function called as sp dot matrix, and I'm arranging x, y, z in it. Next, what I'm doing is I'm creating a variable called as j, and I'm calculating something called as f dot Jacobian what? Okay. F dot Jacobian was. What is Jacobian? Jacobian is a method. It will calculate partial differentiation on f1, f2, f3 with respect to x, y, z. That means this single line of code will calculate, I'll show you that, will calculate from here 1. It will differentiate with respect to x, differentiate with respect to y, differentiate with respect to z. Okay. So that is why we are passing vars to it. What does vars contain? Vars contains a matrix called which has symbols x, y, z. So f dot Jacobian will differentiate. So what is f dot? What is f? F is nothing but our matrix that has all functions, and vars is nothing but it has x, y, z. Will differentiate matrix f with respect to x, y, and z. Next, what I'm printing? I'm printing a Jacobian value. What is Jacobian value? From here, I'm getting Jacobian, the partial derivatives on the all the three functions. I'll be printing. Okay. Next, what I'm doing? I'm evaluating the value of one x, y, z as 1, 2, 3. So that is I'm following this step. I'm starting to follow this step. Okay. What I'm doing is I'm creating a variable called as point. You can see here I'm creating a variable called as point. And in this point, I'm assigning the value of x as 1, y as 2, and z as 3. Okay. I'm creating a variable called as point, and I'm assigning x as 1, y as 2, and z as 3. Next, what I'm doing, I'm creating one more variable called as j underscore evaluated. Okay, j underscore evaluated. And what I'm doing, I'm calling a function called as subs. What subs will do? Subs will substitute the value of x, y, z. Okay, I'm printing the value of that is evaluated matrix. So that is this one. From in our code, I am printing this value. Okay. Next, I'm printing the partial derivative also. So why we are printing partial derivative? As you can see in the question, finding the partial derivative. The question states that finding the partial derivative. If this is not there, we have thus directly asked Jacobian, then till here it is more than enough. Till here it is more than enough. Since they have asked partial derivative, what I'll be doing is I'll be printing the partial derivative. That is, I'll be calling a function called as diff on synpy sp dot diff means differentiate. I'll differentiate function 1 with respect to x. I'll differentiate function 1 with respect to y. I'll differentiate function 1 with respect to z. Okay. If I run this code, how to run this code? If you click over here, it will run. Okay. The procedure is same in terms of Jupyter Notebook also. If you there will be same setup in Jupyter Notebook. If you click on this, it will run. Okay. So now this is the function. As you can see, x squared plus y into z sin x, xy squared plus e raised to y, x plus y plus z. So this is our function that we have given, and this is a Jacobian, it has calculated. Okay. And this is a Jacobian, it has evaluated, and this is the partial derivative it has calculated. Okay. Now we will cross check on this. So first one, differentiate function with respect to x, value is 2x plus cos x. Let us go and check here. It is 2x plus cos x. Okay. Now the partial differentiation on function 1 with respect to y, the value is z. Differentiation f1 with respect to y, value is z. And differentiation on partial differentiation on f1 function with respect to z, the value is y. You can see the value is y variable. As we have seen, this is the matrix for your Jacobian. Now, we will move to the last step. We need to calculate determinant on it. Okay. Now, let us check the code, how to calculate determinant in the code. Okay. In the code, it is very simple. So, your code starts from here. So, we are computing the determinant on it. So, next, so we are declaring a variable called as dit_j. Okay. So now we need to calculate determinant on which matrix? That is J matrix. So we are going to call a method called as .det. .det in the sense determinant. So J.det. So J is the matrix, that is Jacobian matrix. We need to calculate determinant. So we'll call a method called as .det. Okay. So once we call this method, so automatically its determinant will be calculated and it will be stored in DETG. So in this step, what we are doing, we are just printing the print statement, and it will print as Jacobian determinant symbolic, and it will print S. And we are going to print the determinant, that is the calculate determinant, that is determinant of J. Okay. Next, what we have done, we have just calculated the determinant. So how we have not substituted the value now. Okay. So this .det just it will calculate the determinant. If for that, what we are doing, we are creating one more method one more variable called as dit_j underscore val. And what I'm doing is dit_j. What is dit_j? You can see what is dit_j. Dit_j is a determinant that has been calculated on Jacobian J matrix. So dot subs. Okay. Dot subs, as we have seen in the previously, that dot subs will substitute the value, and point in the sense point we have the values of x, y, z that are given. Okay. So same thing will substitute. We'll call that same method det_j dot subs point. Okay. Dot subs will call, which is a method, it will substitute the value of points x, y, z, and it will give the value of determinant of j. Okay. So lastly, I'm printing the determinant of j value. Next what I'm doing is, now I have just substituted the value. Okay. Next, I'm going to calculate its value, that is evaluate. Okay. So now for that, what we are doing, I'm converting it to a float type. Okay. Next, I'm calling a method called as evalf. So you can think evaluate. Okay, evaluate. So what is detj underscore val? So here detj underscore val is nothing but the values that we have got using substitution. So now on that substitution, we are going to calculate detj val dot evalf, that is evalve. So what does this method will do? It will evaluate the values by putting the value of x, y, and z. And lastly, I'm printing it. Okay. Now let us check the output. So this is the Jacobian values that we have got, determinant values. Next step is we are substituting the value of x, y, z as 1, 2, 3. So after substitution, this value we are getting, that is minus 4 plus 4 into cos of 1 plus e square into cos of 1. If we calculate this, so this is the value that we are getting, that is 2.153533 and so on. So if you want to check it manually, just check this. Let's check this. So we are getting same thing. And you can see over here e square cos of 1 plus 4 cos 1 minus 4. So this expression, determinant expression, is same as our determinant expression that we have got over here. That's it for today, guys. If you have any doubts regarding this, you can comment down in the comment section. I'll definitely help you on it. If you like the contents, please hit the like button. So we will meet in the next learning video. Till then, keep learning and keep growing.